So now I'm going to talk about how to use motors. So this is a very important tutorial, and we are actually going to write some robot C code. So it's going to be good. Alright, so first off, we are going to go to Motors and Setup, and then this guy we want to change to Custom, and that'll allow ungrade all these guys, and you have a motor controller, and you can now equip motors. And basically how this works is S1 applies to specifies the port thing that's weird. I don't know why that happened. Yeah, so S1 specifies. Why does it keep doing that? Okay. Do I have to? Maybe it likes. Okay, yeah, that makes sense. So yeah, for some reason it had a mode. The configuration had like a Tetrix servo controller attached to a motor controller. I have no idea why that was like that, because that shouldn't be happening. But yeah, so yeah, basically I'm going to apply that change right now, and yeah. So now you go to Motors, if that's your problem. So yeah, basically these numbers going down, in this indicates that there's a motor attached to the first port in the first motor controller, and this guy is the second one in the first motor controller. If I were to go here and add a second motor controller, then these guys would pop up, and this is as you can see, this is the second controller, and this S1 thing is the port it's in. So yeah, so basically we are going to say there is a motor there and that there's a motor here. And basically, the quick overview of these guys, PID control we'll go into later. Reverse, basically, it'll power the motor in the opposite direction if you run it forwards, which is useful if you're doing like say one motor on the left and one motor on the right, and you don't want to have to make them to say one is a negative value and the other as a positive value, because that could get confusing for obvious reasons. So let's just say that motor E is on a different side, and we're doing that for now. The configuration may change depending on whether people are working on the wiring, so this is also subject to change. But yeah, you'll figure it out. And we're going to hit apply, which is under where my mouse is now, and then OK, and then now we are going to write some motor code. Okay, so now we're in the autonomous file, and we're at the main task main, and we're gonna write some motor code with motor D and motor E, I believe. Yeah. Okay, so what we're gonna do is to set a motor value, you'll do motor and then open bracket, close bracket, and then the name of the motor. In this case, motor D. And then equals, and then you do the power number. Well, how much power you want to have the motor at. So the motor values range from negative 100 to 100. Negative 100 being full powered in reverse, and 100 being full powered forward, and 0 with no power whatsoever. So let's say I wanted to do, I don't know, 40 for some reason. Normally you don't want to do full power because that'll drain the battery faster. Low, generally anywhere, like last year I found that most times anywhere from like 80 was a good maximum or something. I forget. I know I went with 50 or lower a lot of the time, mainly because I had to just drive across the board in the autonomous period for bulldozer. So, yeah. In this case, it doesn't matter as it's just demonstration. And then for motor E, we're also going to do 40 because, of course, the value is reflected. And you always do a semicolon at the end of a line. That is important because it tells the compiler to stop. The compiler will just ignore white space. So yeah, so after you set the motor values, you are still not done yet, because if this program runs, then it's gonna, well, it's probably gonna stop right after setting the motor values, which we don't want. We want it to go a certain distance and not just turn the motors on and off. So to do that, there's a function called wait 1 millisecond, wait 1 m-second, that is, or wait 10 m-second or millisecond. And I'm gonna go with 1 millisecond just because I like it better, but either way is fine. And we're gonna go with, say, it going 40 for, I don't know, let's go with 3.5 seconds, so 3,500 milliseconds, basically. And then okay, so now we've got, what it's going to do is it's going to turn the motors on at 40 and have the motors going for 3.5 seconds and then end the program. So in a competition situation, however, you would probably want to do more than just move forward. You might want to turn, for instance, or like move, then go forward more slowly or something. So what you want to do before making any other moves with the robot is say motor, well, set both of the motors to power 0, because if you give it a lot of commands at once, then it's not going to work as well. It's going to execute all the movement, turning and changing of powers and stuff, more in more time, with less time than you intend, and you generally want to give it the bot a bit of time to slow down from the speed you've got it at, so which is why you set both motors to 0, so that it comes to a stop. So I covered going straight, but I have not actually talked about turning up to this point. And what I did for turning is create 2 general functions, one to turn counterclockwise and one to turn clockwise. And as you can see, basically, if I wanted to make the bot turn counterclockwise, I made the left drive motor negative, which in this, I think we had it, yeah, we had it reversed, so the left motor was running backwards and the right motor was running forwards. And if I wanted to make it go clockwise, in place, I would make it go the other way. What I could also do is set one motor to 0 and set one motor to a power, and that would make it, or I could set the one motor to a lower power and another motor to a higher power, and it would drift. So yeah, that is basically how to use the motors for directional purposes.